Good evening, everyone. So welcome to my YouTube channel. So today we are going to see first lecture on random variables and probability distributions. Okay. So this is a new chapter, you can say, or you can say this is a new topic. Okay. So let us start today's session. So what is random variable? Let's see definition of random variable. Let S be a sample space. Okay. Then a function x from S to R is set of real numbers is called a random variable. Okay. Example. Tossing a coin. Tossing a coin. We have two elements in sample state. We have a head and we have a tail. So we are defining. First of all, you should write in one note. Random variable is denoted by capital letters X, by capital letters X, by capital letters X, Y, Z, etc. and its value denoted by small letters X, Y, Z, etc. So random variable is denoted by capital letters X, Y, Z and its values denoted by small letter X, Y, Z. So now we are taking an example, tossing a coin. So tossing a coin, we have two outcomes, head and tail. So we are defining a function. We are putting, when head is coming, we are putting 1, and when tail is coming, we are putting 0. Okay. So you see that this x is a function. So x is x2 R, because both 1 and 0 are values of R, values in R, because 1 and 0 are real numbers. So it's a random variable. Now see second example. Tossing a coin until a head comes. So what is the sample space? You are tossing a coin until a head comes. So you are tossing a coin. First toss, you got head. Second one, you got tail. Then you will again toss a coin. Then you both head, again tail head, again tail head, tail head. So this process will go ahead up to infinite. So we are defining a function x. So when it is x, I am putting here, then so where we are giving the value of these elements of sample space, where h occurs, that position I am writing. So h occurs at first source, so I am writing 1 here. Now th means when we toss on second time we are getting head, so we are writing 2 here because h is at second position. We are writing this h is third position like this. So if h is an n position, we are writing n. So this is continuing. Continuing. So in earlier example, both was the range of random variable. The range of random variable in earlier example was 0 and 1. So range in earlier, this example, first example is 0 and 1. Okay. And here, what is the range of this range? So what is F? R is, so X is a random variable. And second example, X is on S to R is a random variable. Is a function. Is a function. So this implies X is a random variable. Because any function from sample stage to real number system is a random variable. So in earlier example, this was a function. So that is why it is a random variable. Okay. Function. So this implies X is a random variable. So this is in first example. So in second example, we have shown that this is also a random variable defined like that. So what is the range in the second example of X random variable? Range of X is 1, 2, 3. So range is natural number actually. Okay. So these are the examples. So we move to another one example. Okay. So I am taking x-axis and y-axis. I am taking origin here and I am drawing circles of some radius. Okay. This is x-axis. So these are the circles. What I am taking? I am taking sample space S. So I am taking C such that C is a circle of radius R. I am taking a circle of positive radius. Actually, circle is always of positive radius. But sometimes we can say that radius 0 means point. So we are taking circles of radius at most 5. So I am defining a function. Define S to R by C means CR is a circle of radius R. CR is equal to 2 pi R. Okay. Two pi R. So what is this? So because this is a function, so X is a random variable. Now what is the range of X here? Because we can take radius as small as we can, but it will be greater than 0. So what is this? So this is the 0 will be open because this is parameter of the circle, and R can be at most 5, so it is 10 pi close interval. Okay. So this is the range. We are defining, again, we can define another random variable on S by the following way. In place of perimeter, we can take area of the circle. So a sample space can have a same sample space can have two different random variables. So I am defining a function X CR is equal to pi R square. Okay. Then X S to R is a function. X is a random variable. Okay. So we can take Y there actually, because already we have taken X, so consider here Y, because we are considering two random variables, different random variables. So we are giving two different symbols, it will be better. Okay. So what is the range of Y? The range of Y is nothing but open interval 0. R can be at most 5, so it is 25 pi close interval. Okay. Now we move to another example. Example 4. So again we are taking circles. We are taking circle at origin. of positive radius. And this process is going infinitely. Okay, this process is going infinitely. In earlier example, you write here centered at zero, centered at origin, centered at origin, and R varies from in this. Here, for the example, we are taking as sample space CR. CR is a circle centered at origin and circle centered at origin with radius R, centered at origin, and R can you take up to R can be greater than 0 and less than infinity. So again we are defining random variable x by 2 pi r. So x is random variable with the range of x is 0 to infinity open interval. Because you can take R as large you can. Okay. Now we are defining another random variable can be defined. Variable can be defined in the following way. How y as to r, you put y CR is equal to y r square. Then y is a random variable and what is the range of y? Range of y is 0 to infinity open interval. So what we learn here that a sample space can have more than one random variable. Okay. We see some more examples. So I am taking another example. Example 5. Let x be random variable. Let x be the random variable defined by the waiting time. Waiting time. Okay, in hours. Hours. Okay. Between successive speeders spotted by a radar unit. Successive speeders spotted by a radar unit. The random variable takes on all values of x for which x greater than 0. So x is the random variable defined by the bit in times. In hours, bit means successive speeders spotted by a radar unit. Obviously, the random variable takes all the values x greater than equal to 0. It means what will be the range here of random variable x? Range will be here. Range of this random variable will be range of x in this example will be, because 0 will be there. So this is open. So today's question up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much. We will see you in next lecture.